Hey, how's it going? Just getting started here. About 9 a.m. in the morning here. I think it's now 8 p.m. out in New York, East Coast. I think it's a pretty decent time to have a stream. How are y'all doing today? Over the last 2 days, I've just been doing a little bit of research and study on handling large loading and writing large files with the JSON parser. Pretty much decided not to do or handle the large files yet. It actually probably won't come up for a while, but it looks like in the next major release of Zig, they have it planned to be fixed. So, I mean, actually handling streamed, like generic streamed bytes into the parser. Right now, you have to actually just like pass in a slice. There is a streaming parser, but you have to manually pass in bytes one at a time. So I don't want to actually handle that myself, like actually writing a loop that goes through, pulls from a streaming source and passes into the parser. I don't want to write that additional code for this project, so we'll just put that off for now. Anything new? Anybody out there? Give me a second. It's a little dry out here today. Gonna be a warm one. I think it's probably gonna hit 29 degrees ish here today. Celsius, that is. Oh, 27. That's about what, 80 ish Fahrenheit? 81. Yeah. When you're not in the US, you start thinking in Celsius more than you Fahrenheit. Actually, I should probably post in the chat. Okay. But yeah, today I plan to continue the data serialization stuff. As you can see here, we're going to try to read and write the game's character data to from a JSON file. Well, let's say read write from to and to a JSON. And then we're basically going to set up the test character data and then write it to a file, load the character data. We're also going to load a character data file that's prepared ahead of time and validate its data. It's data, right? And move test code into the game code. That's pretty much all we're going to do today. Hey, Laguno, how you doing today? Yeah, we're doing pretty good out here. Nice weather. Got a lot to do today. But we'll try to get as much as done as possible. Yeah. I hope you all can hear me out there. The volume level's decent enough. Okay. Well, I just want to do a quick review of what we did last time. We basically just wrote some test code to try out this JSON parser functionality that comes built in with Zig. Yeah, so we just tested reading a text file raw, right? Like, and just running those tests. Right now, all the tests pass that we rewrote. Well, I think they do. Yeah. Test writing a file, test writing a struct to a JSON file, and test parsing. We didn't actually test anything here. We just put output. So, as you can see, test reading. So, test writing text file. Yeah, test reading text file here works. Yeah. This was actually the output. Anyway, we saw you can open a file like this, read it all into a buffer. You can write it all out at once, and you could read it all in. You can also read it all at once, There's also ways to do streaming, but we didn't really mess with that. Streaming just being 1 byte at a time. Okay. And yeah, here we created a JSON file. We had a test data structure for serialization, and we created a buffer of 1024 bytes. Uses fixed allocation buffers. It was storing in this buffer. Created an array list for the string, and then we stringified it using its writer, and then we wrote it all to a file. Okay, and then we have the parsing stuff too, which is basically again, we created a buffer, read all these bytes from the file into the buffer. Since we knew how many bytes were read, we can create a slice of that size, right? And that message, we want to create a tokenized stream for JSON, which you would turn each string inside that JSON file into a token, or each bit into a not bit, but yeah. Anyway, created another allocator here. We needed that because we had strings in our JSON file, as you can see here, and we parsed it, passing in the stream and the allocator. And then we validated the data, and so we can see that passed down here, right? Okay. And we're going to do a test streaming parser, sorry. But then I just kind of gave up on that. So, because that actually required me to do, interesting, wait, did this pass? Did I not save the file? Is that why? I bet it's not gonna work, right? Yeah, so we need to delete that. We don't need this. We're not gonna do the streaming parser. Okay, so that's pretty much where we're at. So what I want to do now is we do want to parse a JSON file, but we want to parse our game data now. And our game data is a little more sophisticated than this simple structure. Hold on. Oh. Unfortunately, it seems like allergy season is back. Got multiple allergy seasons here in Japan. Okay. Here we go. Let's see. So let's look at our character data. Character data. Okay. So our top level structure, right, is this character properties, which stores a list of actions, and each action will have a list of et cetera, et cetera. So what I want to do is we have these tests for creating and validating character data, right? Test adding an action with Hitbox to a character. So we have this test code, right? If we run the test on that, we can see, let's see, game simulation, it should run. Yeah, so testing, this is called testing adding action. Testing adding action to a character with Hitbox to a character. So that passed. So we're going to actually take this, not the test itself, but we're going to take the code for setting up here. Bring it to our, we're going to bring it over here. We're going to test writing it first, okay. Just to see what the output will end up being, right? And they also give us like test data to load. This is kind of just an exploration thing right now. So initialized game data is not available in this file. We have to make it public, I think. Yeah, oh, it is public. So, well, the first thing we need to do is import game simulation, right? So we do that in the main, right? Or are we doing game? So I can just take that code real quick, put it into the test here. It will be, should be source, right? And then instead of initialize game data, we can have Actually, we don't need this in particular. Sorry, I didn't want that. We want character data. Sorry, character data, and we want to have this. We don't need to initialize because we're not actually going to be appending it to here. We're just creating a character with an allocator here, creating an action. We're not doing this at all. Hold on. Oops. We just want to do character, not characters. We just want to do. We just want to add it to this character, right? Not the characters, but character. Okay. And then we want to do the character outside action, and we don't need to test any of this stuff, right? So just to review what they have this here. So we created a character, created an action, added no, we just need character action. So we added action to the actions here. Then we added a hitbox to the first action in the vulnerable hitboxes. Okay. So just to make sure that actually builds here, builds or the test runs without crashing or doing an error. Not crashing. Error found 92. What's the issue here? Hold on. Oh. Anyway, let me comment this down real quick. And then import a file outside package path. So that's an issue. Okay. Then we'll just have to move this code. Okay. Let's just move this code here to the character data. We'll start testing here. Instead of using character data, well, we can just do, since we're in the same package, we can just do this. And then we can test the character data, I think. Error local shadows collection hitbox group. 115. Oh. Sorry. Oops. Use of undeclared identifier hitbox data. 117. Okay. That's weird. What? Okay, here we go. Error ignored. 117. Okay. And we do try. Gotta get used to doing the try here. That's important for like catching the errors. Okay. So that builds. So we have that. So let's try to serialize that out. Let's look at our test code again. Test parsing JSON file, test writing a struct to JSON file. So let's just copy this code. That's why we wrote it the other day. And let's go drop it in the test we have here. Let's try to write. So we don't need data here. We do need a file. Let's just drop it to prototyping for now. Let's call it character data test, whatever, test. Okay, character data test. We'll close the file, we'll defer it, and then we'll give it a 1024 bytes. Hopefully that'd be enough for what we're doing here. Create a fixed allocator, string it, and we're going to stringify it. We actually need to assign the buffer. So that instead of data, we need the character. Okay. We're going to write it. Let's see if that does anything. What's the problem? Unable to stringify item type. So it's going to try to stringify functions. Like, yeah, I don't mind you asking. We're using a library called raylib, which includes things like loading images and rendering them to screen. It's just going to be 2D for now. Everything's going to be 2D. In the future, we might change it to something like SDL or whatever, but I'm sticking with raylib because it's a very simple to use library that's well documented. If you actually look here, we have a raylib, and basically you can just drop in here and look at all the functions really easily. And Zig already has there's already a library implementation for Zig, so that's what we're using. Anyway, going back to the code. So it looks like there's an issue with serialization where it's trying to serialize a function, which obviously you don't want to do. Error unable to stringify type function NEOP type void. Unable to stringify type blah 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 blah. So what if I try to stringify just the hitbox group? Is that fine? No, even that's going to have an issue. Huh. Well, that's interesting. What about just an action? Can we stringify the action? Not even that. Okay. Keep saying it's unable to stringify this function thing. Is it because we have functions in here? Hitbox is like the simplest thing. We do have a knit function for it though. Can we just let's see? Can we stringify just a hitbox? That should just work, right? Just a hitbox, a plain old data structure. That should just work. Let's just make a hitbox. So var hitbox equals hitbox. Do we have a default for hitbox? Yeah, we do. So let's try just stringify hitbox. Even that's throwing an error? Oh. Too many parent directories. It hates this. It doesn't like me doing this. Okay. Let's just dump it here for now. Okay. So we should have test character data here somewhere. Yeah, right there. So again, outputted it right here. Okay. So yeah, it did output the fields, but not, it doesn't, when it serializes, it doesn't include the name of the type, which is kind of what I expect. Okay, so we do have an issue trying to stringify things that are like, that have functions in them. It doesn't like to do that. So we might have to rethink a little bit how we handle our data. Like, it looks like even giving me accessor functions becomes a problem. Let's just check a quick thing. So Zig JSON stringify stringify nothing clearly pops up on there. Okay, oh wait. 119. Yeah, let's just get rid of that. Okay. Error, unable to stringify type. Yeah. Let's just search for that real quick. See if I get anything here that's useful. Okay. I'm surprised it doesn't just skip functions when it stringifies. So let's just look at the code itself. Can we go jump here? I should have it open here somewhere. That's OS. Okay. So looks like it does a switch on the type. And if it's interesting, they didn't actually print the type name. Oh, it did actually, sorry. Yeah. So we try to stringify. It tries to stringify field name, but it doesn't say what the field name is here, does it? And finally, we get to a field name. Okay. This should be a stringify function called stringify, right? Yeah. So it looks like it handles float, int, bool, null, optional, enum, union, struct. Pointer. Yeah, it doesn't handle functions. I thought I would hope it would just ignore functions. Handles array and vectors. Okay. Oh yeah, stringify options. What do we got there? Also, there's a lot of tests right there. Let me get the top of this. What options do we have? How many indentation levels we have? What character should be used for indentation? After colon, should the white space be inserted? White space, string options. I don't know what that would be. Okay. Nothing about functions, ignoring functions or anything like that. So we have kind of a. So it looks like we can't stringify to JSON structs that have functions in them. We could do a quick test of that. So the tricky thing is, you know, it seems so far the pattern for handling structs that have dynamic memory is to give it an init function, right? A init function that can actually go in and itself use an allocator to reserve memory that it needs for its own state. So what does that mean for us? So, like, for example, you know, the hitbox group, it needs to have this has an array list with a dynamic memory, right? So yeah, really, what can we do? I mean, one possibility is have runtime data structures and then structures that are used just for the data assets, which then references them. Kind of annoying. That means we have to have 2 structs for each type. Just because the functions are not ignored by the stringify library. That really sucks. It's not really a hurdle I was really thinking about. I wonder if there's some way to get past it. I mean, in theory, we could write like construct hitbox group function instead of having init on itself. We could do something like, let's just do the hitbox group here real quick. We can move this outside here, make a function called like hitbox factory, right? Hitbox group factory, which is a standard kind of pattern. And here you pass in an allocator, oops, and it would just return hitbox group with hitboxes in it. And then we'd get rid of this, right, in theory. It's still not going to be able to parse this, I'm pretty sure. But we're going to get an error for sure. Just give me a second here. Oops. So hitbox group dot init is used all over the place. Oh, this used here. So we don't use, instead of using that, we would use hitbox group factory. Sorry, in this second. Yeah, so go to this function. So because we have this is active on frame utility function, we're now kind of like stuck, right? Really, still didn't parse. Enable stringify type. There's no more functions on here though. Is it because of the standard array list? What is a way to break on? What should we do? No. What is this function? Where does this come from? It's it's probably because we can't. Okay, we can't just stringify array list. Stringify isn't clever enough to handle this complex data structure. That's a problem. Well, boy. What are we going to do? Yeah, because it handles these basic types. It handles a struct, but comp time admitted trait has function. JSON stringify, return JSON stringify. So if the struct has a stringify function, it will call the stringify function. So we could technically implement a JSON stringify function per struct, it looks like, and handle it ourselves. It's interesting. That's one option. So we can not have to deal with that problem. But yeah, it's looking like if we don't have like plain old data as our and I mean plain old data by not having like anything allocated. And you need this function to handle the allocation stuff. It's not going to be able to easily stringify this stuff. What if I type zig JSON stringify array list? Is there something that handles that? Nobody even mentions that. See, this is not even zig. Zig. This is just the code, right? Wait, hold on a second. What is this? Parse internal. If it's okay, so if it's a slice. If it's a pointer, if it's a slice. Oh, that's a different part. Huh. What should we do? So something like Unreal Engine would support their own form of arrays, like T-array, which is a dynamically allocated, or can be a dynamically allocated array, resized array. That is actually serializable pretty easily. Now the fact that we don't have an easily, wait, does T-array have its own? Sorry, not T-array. Does array list have its own serialize function? No, it doesn't. Oh, hold on. No, it doesn't have anything like that. No stringify. So yeah, this. Test stringify struct with custom stringifier. This is what I was talking about. Has having a custom stringifier to make a struct, and it takes value options outstream any type, and it'll just write by hand the output. So you can see like consequences of us picking a certain type of runtime data structure has led to another part of our work being much more difficult. So the early decisions end up being important. It at least leads us to a point where we need to make a choice here, right? whether or not we have kind of offline data structures that are separate from our runtime data structures, or we start just get rid of the current way of handling things. We would have to get rid of using array lists, which makes it a little more difficult when we want to start constructing game data using an editor. So I plan to have like an engine editor. Yeah. What should we do here? Okay. Let's just look through here a little bit more so we can find anything that's useful. Let me get up for a second. Be right back. Okay, I've returned. So now what I'm thinking is we really have two choices. Either get rid of using array lists entirely, which doesn't allow us to have dynamically resizable list of things, right? Like hitboxes, and which during gameplay we don't need. It's only so it's convenient for us to do tests and generate data. But if we did make that choice, if we do have some kind of editor, we need a separate data structure for basically each struct in our game, because we're going to have to be able to dynamically allocate memory to be used to resize those things. I mean, there's other options to keep pointers to a thing and keep track of slices, and we could keep memory in a separate area, and then it's going to become very hairy very quickly, and something I don't want to deal with, to be honest. Yo, Johnny Marler, just trying to figure out to serialize more complicated data structures into JSON using the built-in stringify function. Turns out that there isn't a implementation for, as far as I can tell, stringifying array lists, standard array lists. So we're trying to figure out what to do about that. So along with that one option I mentioned, the other thing I was thinking is implementing our own custom array list type, which can be serialized. So that's also a lot of additional work as well. So I don't know, or maybe just a wrapper around it, right? Wrapper around standard um, array list that lets us serialize elements of the array list. Yeah, thank you, Jamar. You're probably completely correct about that. The issue is that the way that's because we have a hierarchy of these things, right? We have a character with a list of actions and a list of hitbox groups within those actions. There's a JSON convert serialized object. Is that in the standard? Is that in the standard library? Well, nothing is popping up on Google. We're programming in Zig, so I'm not sure. Oh. Yeah, I think what you're talking about, Johnny Maurer, would require us to implement our own JSON stringify function per struct, so that we'd have to manually. Yeah, it's probably C#. We're actually programming in Zig here, which is a fairly new programming language. That, yeah. Yeah, this is kind of a pickle here. What should we do? But yeah, going back to the one solution I was talking about, we potentially either wrap, and I don't know if you can do this, the standard array list, and then implement a custom JSON stringify function within that wrapper that then can just look like doing what Johnny Mahler is saying, is going to look at the items directly and then serialize that. I don't know how difficult that would be to implement, if at all possible, in Zig. Yeah. Now, if we were to create our own dynamically resizable array type, that is very useful for games, and many game engines choose to do so, such as Unreal. Not use a standard library, because again, like things like the standard library in C++ don't have easy serializable dynamic array structures. C++ is the whole thing. It doesn't even have proper reflection in the first place. So, yeah, it is definitely it is a pickle here. We have a lot of potential choices to make. Either way is going to be time consuming. And honestly, I don't know what would be the quickest way to, like, say, just override or add additional functionality to the standard array list, right? I mean, one thing we could potentially do is, like, let me just, I'm just brainstorming here. Is we'd make a new, like, const, like our array list. It's gonna be a struct, and you would have something like, I don't know, data would have to do something like this. I think, I'm not, sorry, I don't know the exact way of handling this, but the data would be some array list, right? With a type, and I forget how, I don't know how to do all this, so I'm just sketching here, right? And then you would have our own function that's like function, is it semicolon, or, sorry, No, it's not C++. My brain is on that. So yeah, you'd have like a function like JSON stringify and whatever arguments, and then you would like do like what Jason Mahler said. So as far as I can tell, Jason Mahler, Johnny Mahler, not Jason Mahler, Johnny Mahler. So, oh, as you just saw, sorry. So the actual stringify function will call a custom JSON stringify function on your data structure. Yeah. So if it has the function, it will call it. So standard meta trait has fn, it will call that function. That's funny, Necromancy. Yeah, that's not helpful. Yeah, sorry about that. So, yeah, that's what I'm thinking exactly, Johnny Mahler, is just make a custom function that wraps it. Yeah. So we need, what is the actual type of this? So there's actually a test here, right? They wrote a test that kind of demonstrates what you're supposed to do. That's not the test. The test is down here. Yeah, so custom stringifier. So they make a struct. What is this whole const self this pattern about? I still not quite sure what's just the type. It just gives you the type of whatever this is. Okay. Like, why wouldn't you just use this all the time instead of self? Anyway, yeah, they do something like this. So I would just take this and write. Sorry, I'm just sketching here. And they would have to do. So we actually do have the self. This would have to be like JSON. Would it be standard JSON, stringify, whatever? Oops. Oh, ArrayList is a function, actually? That makes sense. Maybe. So what we'd have to do, we'd have to... Give me a second here. My brain is thinking a bit. I'm still trying to get into the mindset of Zig programming, right? The fact that this is a comp time function that generates a anonymous struct. Yeah, that's what I'm thinking. Yeah, I'm trying to get into that mindset. So it's not a struct. It would be a function, right? So pub function our array list, instead of being this, it would be comp time. What is it? Oops. Not going to the definition because of things, but comp time t, and data would be, yeah, instead of having that, we have to make a new struct, right? Return struct or something like that. To return a struct, sorry, where Oh, it returns a type. Okay. Returns a type. Got it. Oops. So returns a type. Given a type, it returns a type. Just learning from the library here. Thank you, Tries. Yeah, I think I was assuming that was the case. I was just wondering why there was such a pattern of like creating a constant that was equal to this. Is it just so they don't have to write this like this all the this all the time? I just in the center library I was commonly seeing this pattern of yeah. Basically, why use self when you can just use this is my question. Maybe because I guess there might be reasons for it, like other than convenience. But yeah, so can we? I wonder if there's one more thing to make this easier, right? Yeah, we generate an array list. Or our array list, right? Our array list. And we do have a data that would point to an array list like this, right? What would it be? Type? Does that work? I mean, that's what we generally do. It's like this, okay. And we implement our own JSON stringify function. But what I'm thinking about is the case we're actually already using this array list, right? Like here, actions append. Is there any way to kind of like take those functions that are already part of this data and default to that, I guess, right? When I'm calling, is there a way to call the function? Like, is there something to do? I don't know. I don't know if there's any like useful way to do that. Like kind of forward the function calls onto the array list, so that I don't have to write like whatever data structure dot data every time. Just an additional additional stuff that doesn't seem to need to be there, just so that I could wrap this around. I'm gonna call it serializable array list, right? So I'm gonna call it. There's no way to do that. That sucks. Just to get serialization, I have to introduce another level. It's like the least worst option, but yeah. Well, for now, I want to go here and take saw something down here. Oh, no, it's not important. Where was that? Parse free. Stringify. Okay. Yeah, so I was going to go through here and just kind of take their implementation of So yeah, I should be able just to like stringify. It would be like data dot items. Items would be a slice, right? Yeah. I could write your own serialization. Yeah, I mean, sure. Write my own serialization function that handles array list. Yeah, I could write my own function that only handles the special case of array list. Not a bad idea. So I would just like take each value, call my own version of stringify. If it's array list, do this. Otherwise, call the normal. That's not going to work exactly. Well, yeah, I could just copy the whole thing. Yeah, I was trying to avoid that kind of stuff. I didn't want to get so much in the weeds with this. I think it's better than having to add like whatever dot data or whatever dot items dot data dot items each time I want to use an array list. That's serializable. What if there's anything else a little more that we could do? Hmm. Um. Well, how many types do you think you need? Sorry, I think the only thing that, off the top of my head, I need to worry about serializing is standard array lists, and maybe, well, probably I'll want to serialize hash maps at some point, right? I think it's gonna be useful to be able to serialize hash maps. So, yeah. Hmm. So I'll have to write a function that handles hash maps and standard array list. This is not a terrible option, right? It's just more code to maintain, right? Because of nested data structures, I can't just easily like, oh, man. Hmm. Yeah, of course. Well, serializing manually means I need to also write serialization functions for everything, right? Hmm. Because I can't call the standard JSON stringify function because it's going to try to it'll look into a struct and see that it has a type it can't handle when I have nested standard array list and hash maps, and then it will just throw an exception or cert or an error or whatever. Yeah. Hmm. So we're saying Johnny Mahler is I can go through and have like, so the Hitbox group, I will have like, which actually is great because I can come back and actually have functions like this again instead of using a factory function. So I would just serialize my, yeah, I'll just do like what? Try stringify start frame from this case, and then duration, and then hitboxes dot items, and then I would have to do insert. Would have to insert a sorry. Instead of this being array, it's not array. It would be a. Oh, I would have to do more than I'm thinking now. Oh, you're actually very clever there. You're very clever. I see what you're doing. So I would have an anonymous struct, right? Instead of doing all of this, I'll just have an anonymous struct that it serializes. Is that? I don't have to write the struct keyword. So yeah, I can just wait. So that works. I could have like start frame equals self. Well, sorry, give me a second here. The JSON stringify. Hold on. What am I missing? Yeah, wait. Why is this? It doesn't take self though. Look at the last test in JSON.zig. Yeah. Oh, okay. That makes sense. That makes total sense. But I was like thinking, hold on. What do you, I'm trying to articulate what I'm thinking here. Like, well, I should just write it and see what happens here. Let's just do a quick test. What? Okay. Let me store this code real quick. Yeah. Okay. Let's just do. Yeah, let's just do the anonymous, plain anonymous struct here. I really hate this. Okay. Why is there a comma here? Why is there a comma there? Anyway. So value is ignored. It doesn't need to be ignored though. What? It's kind of interesting. They have a custom stringify, but they don't actually use. Okay. Then we don't need that. We need. Wouldn't it be something like dot start frame equals value dot start frame? Wouldn't it be something like that? Sorry, I'm just. What? Now we could uncomment this. And sorry. Come back here. I'm sorry, just gonna call the test now. Oh. Oh, I don't need this. Wait, hold on a sec. Oh, I don't need this anymore, actually. Sorry. Let's get rid of this entirely. Oops. So const self equals this or this. So that passes. What? So what? Do we get output here? Hold on. Oh, there we go. So, hey Melon, how's it going? Thanks for the well wishes. Hope you're doing well as well. Yay, yeah, we're streaming regularly again. Finally got some stuff taken care of. Haven't got my visa renewed yet, but that's a different story. But yeah, Johnny Mahler came to same day once again with a very great suggestion of implementing our own custom stringify function per data structure we need to handle T arrays and maybe hash maps into the future. It's a really great idea, and I thank him for it. Give him a round of applause. So now we can do things like this. And then hitboxes will be equal to hitboxes dot value to hitboxes value dot hitboxes value dot hitboxes dot items, which I think is just a slice, and that should work. And if we look at character test data again, yeah, so we got everything gets outputted here. Oh, cool. Came back from Combo Breaker. How was that? I really wish I could have gone, but price of plane tickets is way outside my budget, and just with all the precautions we have to go through returning back to Japan, I just couldn't take the additional time for quarantining anything that would end up being would happen if somebody tested positive on our plane. Let's see. So that's cool. That works there. That's awesome. I can accept this additional overhead for each structure we're using in the game. It's not terrible at all. So now if we go down here and we have actions, so if we say oops, and if we do like hitbox group data dot hitboxes append, we can do what? Add a new hitbox here. Should that work, right? I need an allocator. Oops. Wait, I don't. Sorry, just trying to get intuition for things are now completely not there. That was a lot of error messages. Oh. Try. I'm still not in the habit of that. Using try. So I think I just do this, right? It's can infer the type. And then we look here again. Cool. We have hitboxes. That's awesome. That's exactly what I wanted to do. Thank you again, Johnny Mahler. Saving the day. So one thing though we noticed, everything's printed out on the same line. So I think we need to pass in these stringify options that would actually put everything on a separate line. Otherwise, source control is going to be a big pain in the ass. Because we want to be able to like easily diff these files into the future to see what things changed. This is something you really should take into consideration, is like how easy to source control or version control your game data is. Some engines do everything in binary, so it's not easy at all. Others choose to go with text data, at least for the intermediate files, not the actual cooked files. I think ultimately when we cook the file, we'll probably dump it out into some kind of binary data, but that is far into the future. So let's let's look at the stringify options. What do we have here? We should have something to put everything on a separate line, hopefully. Like, home equals. Space tab. Wait. Okay. After a colon, should white space be inserted? Wait, is there a way to put a line separator per value in JSON here? Or is there a way to format it at least? Because obviously we see like white space handling. Oh wait. Let's just look at this real quick. How's white space used? Is there any tests that use the white space option, just so I can look at it and follow their example? I'd rather do something like this. Is that the right one? Yeah. There we go. Just add white space to the stringify options, and we suddenly have white space now. We get indentation. This is awesome. And how long we're on here? About an hour and 16 minutes. Okay, I want to do one more test of it, and then we'll finish up. While I do that, feel free to ask any questions, say hi, whatever, and then we'll call it a day. I think this is great. I would have not have thought about that. I don't know why. It's like the way Zig works. It just makes that so pleasant to write a simple little serialization function. Yeah, like just that's so easy, really. Honestly, that really makes my day. And now we can do it for this here as well. Then we'd have like duration. And then So does that mean we can serialize action now? The action we created? I made an error, didn't I? Oh, oops. Brain. Hey, what's up, X-School? Long time no see. And so we get duration, vulnerable hitbox groups, attack box groups. Did we not add things to the action, though? In our test data? Oh, we added it to the character directly. Gotcha. So if you just do, for now, hold on, I'm gonna take that. We're just gonna do action just to see. Okay, so we can see we have an action with duration, vulnerable hitbox groups, and attack hitbox groups. With all the stuff there, that works. So we can go up to the next level, I think, and then support character. This makes things a lot easier. Okay. So all you have to do is just copy this function now. And just put each item we need in here. So honestly, I'm going to put the function at the end. I'll probably reformat that. Okay. And then we have max health. So we need to assign max health. And then we need actions, which will just be actions dot items. Okay. Easy peasy. We don't need anything else there. So that should work, right? So now we can just stringify our character. Hopefully. See, that's why I like to have people working here on the stream. This the helpfulness of you all is just unbelievable. So now, yeah, we got our max health here. We got our actions, and then we can control precisely which which properties actually get serialized. Because maybe in the future we'll have like runtime data that shouldn't be part of the game data itself. Shouldn't be saved, and we could use this for a save system as well, right? That's awesome. It gives like precise control over how things get serialized. So this is actually great. Instead of just automatically serializing everything perfectly, this gives us precise control, like I said before. So yeah, we got actions inside of actions. We have one action for now, with a set of vulnerable hitbox groups. One group. Yeah. So all that stuff gets serialized. It's awesome. So sweet. And you know, if we wanted to, we can append another empty action, just for the heck of it. And we would get, yeah, we get an empty action here. First action, second action. Cool. Well, I think that's pretty much what we wanted to achieve for today. I don't think I would have got there without Johnny Mahler, to be honest. So yeah, very valuable resource we have on the stream here. So yeah, that's gonna be it. Let's just mark off. Well, we'll continue with this since we have a direction to go, and then we're gonna have to write, a parsing function for each of these, I guess. Probably, yeah, because we're gonna have to properly generate a standard array list from the JSON data itself. I'm sure it's gonna be something along the similar lines. So, no, again, much appreciated, Johnny Mahler. You've unblocked us, and that's a critical thing. Okay, let's just say P for in progress for that. We've already kind of moved it into game code there. So, yeah, that's it. Thanks for stopping by. Hope you all have a good evening, good morning, wherever you may be in the world. I will continue with my day. Probably head to the gym here or something. Get a good lunch, burrito, I think. But yeah, hope to see y'all again. Thanks for dropping by. Until next time. Peace.